All right. So the first topic that I have there is uniform distribution. Any question in regard to the uniform distribution? And if you do have a question, you can either yell out that you have a question, or on the chat you can give, yes, I have a question for uniform distribution. All right, no question for uniform distribution. Like the main thing for uniform distribution, the data set has to say is a uniform distribution. All right, so if the problem doesn't say anything about it being uniform distribution, then you probably shouldn't use uniform distribution for that problem. All right, let's do number 2. So number 2 says find this probability for a standard normal distribution, so Z value. So if you kind of remember for this one, when I say probability Z is greater than like 1.35, and then you have to find that probability. Do we have any question for that, for topic number 2? And like a good review for topic number 2, if you go to the quiz where I told you like find the probability that Z greater than, less than, or in between two values, like you do want to use that quiz as a reference point for it, because very similar question will be on it that I put on the quiz. Any question in regard to topic number 2 on chapter 7? All right, what about topic number 3? Find the Z value when the probability is given. So probability of Z less than A, which is equal to a percentage. So if you remember for this one, probability of Z less than A, and then I tell you is equal to like 15%. Is there any question for that topic?
Oh yeah, I have a question. We only use inverse norm if if the side with shade is on the left side, right? Either. So basically, let's say we're giving that that so our A is on the left side of the graph. If that makes any sense.
Well, here, let me kind of give you like a breakdown of this one. So if you have a Z value and you want to convert it into a percentage, this one's going to be on normal CDF. But if you have a percent and you want to convert it to a Z value, that one's going to be inverse norm. But just remember for inverse norm, the probability is always to the left.
There, yeah.
So if I tell you, say, find the probability that Z is greater than A, which is equal to 0.30. For this one, you wouldn't put 0.30 in inverse norm because the 0.30 is for the right side. You want to tell the probability to the left is 0.70. So you kind of memorize, or you kind of understand that if you want to get a Z value and convert it to a percent, you use normal CDF. But if you want to get a percent and convert that to Z value, that's when you want to use inverse norm. So problem like these, inverse norm. Problem like these, normal CDF.
No idea. Thank you.
Yeah, you're welcome. All right. So let's do topic number 4. Find the probability for a normal distribution. So this one is a little bit different from topic 2. So topic 2, if you remember, you start off with the Z value. In topic 4, you start with an X value, and this one you convert it into a percentage. So you'll get something like this where you say, find the probability that X is greater than 20. And for this one, you have a mean of, 27 and a standard deviation of 10. So that's what topic 4 is talking about. It is saying you want to be able to get an X value and convert that into a percent. Any question on how to do that? All right. So we're all done with topic 4. Topic number 5, assessing normality. So if you kind of remember when we're assessing normality, we use the normal probability plot. So for the normal probability plot, just remember it's essentially saying these are the value of Z corresponding to the X value. So for the normal probability plot, if you kind of remember, that's at the end of chapter 7. So for a normal probability plot, if you have a somewhat straight line, we say we have a normal distribution. But if we have something that kind of has like curvature to it, I mean, it's exaggerating here, we will say it's not normal. Like, it's okay to have a little curvature, but you're not supposed to have that much curvature if it is a normal distribution. So for a normal probability plot, if it has a straight line or it appears to be a straight line, you say it's a normal. But if you have something that doesn't look normal, if it looks kind of curvature, then you want to say that it's not normal. All right, but that's it for topic number 5. Any question in regard to topic number 5? All right, so that's it for chapter 7. So everybody hopefully should be good for chapter 7. All right, let's go chapter 8. So for chapter 8, if you look at it, it says CLT, which hopefully you know stands for central limit theorem. And if you look at it, it says central limit theorem for mu. So for the central limit theorem for mu, what's the only condition that you have to check for? Start with an N. So what does the central limit theorem say about the mean? Cool, perfect. Well, not greater than, but greater than or equal to 30. So you just kind of know if you have the central limit theorem and it's for the mean, in order to check to see if your data set is approximately normal, all you have to do, you check to see if your sample size is greater than or equal to 30. All right. So that's topic number 1. Any question for topic number 1, or you want me to go more into detail for topic number 1? All right, let's go to topic number 2. Describe the sampling distribution of X bar. So to describe the sampling distribution of X bar, this is where you're going to give me mu of X bar, which is mu, sigma of X bar, which is sigma divided by square root of n. And also you're going to give me if it's normal, not normal, or approximately normal. So when I said describe the sampling distribution, you're going to give me mu of X bar, sigma of X bar, and you're just going to tell me if it's normal, not normal, or approximately normal. But that's what I want when I said describe the sampling distribution of X bar. Any question in regard to describe the sampling distribution of X bar? So let's go 3. So for C, 3 says find the probability for a sample distribution of X bar. So for that one, is when you have probability of X bar, and it could be greater than, I don't know, let's just say 30. So for this one, it's essentially kind of like topic number 4 on chapter 7. But the only thing different for this one, you have to remember when you do normal CDF. So you put the lower bound and you put your upper bound. And if you don't find the mean, or let me see, if you don't find the Z-score, you have to remember that you want to do mu, and you want to put sigma divided by square root of n. So you have to just remember to do normal CDF, do the lower bound, the upper bound, whatever the lower bound, the upper bound is, and then make sure that you tell it the mean is mu, and tell it standard deviation divided by square root of n. Because if you don't do that, it will give you a drastically different answer. All right, but that's it for 3. Any question for 3? All right, so let's go to topic number 4. Topic number 4 is central limit theorem for proportional data set. So the central limit theorem for proportional data set, you kind of have to remember that is n times p times 1 minus p, and that has to be greater than or equal to 10. So if you remember, this is how you check for large sample size. But for this one, there's also where you have to check to see if you have big population. So I'll put big population over here. So for big population, what you have to do, you have to get your sample size, multiply it by 20, and that should be smaller than your population. So usually you're not going to know the population, but you can kind of rhetorically, you have to kind of think about it, and you go like, is my population bigger than 200 or 2,000? If the answer is kind of yes, then you say we do have a big population. If the answer is no, you say no, we don't have a big population. But just remember, for the central limit theorem for proportional data set, you have to check n times p times 1 minus p. All right. Any question for central limit theorem? All right, so if you look at topic number 5 says describe the sampling distribution of p hat. So to be able to describe the sampling distribution of p hat, you need to know mu of p hat, which is equal to p. You have to find sigma of p hat, which is equal to the square root of p times 1 minus p divided by n. Cool. And then you also have to just remember to do this, where you do normal, non-normal, or approximately normal. So if I do say describe the sampling distribution and it's for a proportional data set, that means you want to give me mu of p hat, sigma of p hat, and you just tell me if it's normal, non-normal, or approximately normal. So that's topic number 5 for chapter 8. Any question in regards to topic number 5? All right. And then we have topic number 6. Topic number 6 says finding the probability for a sampling distribution of p hat. Yeah, that's what the p stands for, proportional. So yeah. So topic number 6 says finding the probability for a sampling distribution for p hat. So for this one, it will be find p where p hat is greater than some percentage, and you want to find that percent. So for this one, you want to do normal CDF. You want to say what the lower bound is, what the upper bound is. But for this one, what makes it different from the normal CDF for when you're trying to find the probability of sampling distribution of X bar, what you want to do, you want to enter P, and you also want to enter square root of P times 1 minus P divided by N. And this will be your mean of p hat. This will be your standard deviation of p hat. So just remember, if you don't want to go ahead and find the z value, you do have to just remember for mu and for sigma, for mu you enter p, sigma you want to enter the square root of p times 1 minus p divided by n. All right, but that's it for topic number 6 for chapter 8. Any question in regard to that topic? Wait. All right, so let's go on to the last chapter, which is chapter 8. Oh, sorry, chapter 9. All right, so for chapter 9, if you look at it, it says confidence interval for P. So you kind of remember for this one, if I don't really ask you to show your work, or if I don't ask you like question A, B, C, and D, what you could do, you could just do this in your calculator, and the function in your calculator is 1 prop z interval. So if I use actually to find the 1 prop z interval, pretty much that's what I want you to enter. And also for the test, the way I'm going to do it, you're going to have something that looks like this. So say you do 1 prop z interval, and it give you that between 0.20 to 0.30. What you have to do, right here, you use enter 0.20, right here, you enter 0.30. So if you see something like that, you shouldn't get freaked out. It is asking you for the confidence interval, and it is asking to put the lower one on the left-hand side and put the upper one on the right-hand side. But any question in regard to topic number 1? And also just remember for topic number 1, you have your margin of error, which is equal to z multiplied by square root of p hat times 1 minus p hat divided by n. And just remember for this one, the point of estimate. So when you put PO for point of estimate, it is equal to p hat. And then also just remember, in order to find this z value right here, you do inverse norm. So for topic number 1, you should know how to get margin of error. You should know how to get the point of estimate, and you should know how to get the z value. All right. Any question in regard to topic number 1? All right. So then you have. Yeah, what's up, Julian?
Can you walk me again how to find the confidence interval on the calculator again?
Yeah, cool. So let's make up a problem.
All right.
So let's say if we're trying to get a confidence interval about how many people are in the classroom, or how many people are paying attention to the lecture. So we'll say we have a total of, I don't know, 34 students, and we have 17 of them are listening to the lecture. So say we want to get like the true proportion of students who actually listen to the lecture. So we want to have a 90, let's do something different. We'll do a 92% confidence level. So for this one, if we just want to do this in our calculator, what we'll do, we'll say, well, here, let me get my TI-84 up. All right, so we'll go to the TI-84. Cool, so we're there. So what you want to do, you want to go to the stats button. You want to go to test. And you want to go right here where it says, that's it, no, it should be it. You want to go right here where it says 1 prop z interval. So if you are having like trouble trying to memorize where everything is on the calculator, like you might want to do notes on just like how to find things on the calculator. So you should do like 1 prop z interval or a t interval. So for 1 prop z interval, you click there. So you put x. X we said was 17. N was 34. 34. And my confidence level was 92. Also, you kind of know your calculator also, like if your calculator doesn't like it, if you put 92, if you have to put 0.92 for the confidence level, then you put 0.92. So you go to calculate. And if you look right there, it'll give me my confidence interval, which is 0.3499. I'll round it off to 4 decimal places, and we get 0.6501. And also, if you look at the calculator also gave me p hat. It told me p hat is equal to 0.50 or 0.5. So. And that's how you want to do it in the calculator.
Thank you.
Yeah, no problem. Right. Any other question for topic number 1? All right, so let's go to topic number 2. So topic number 2 says determine the sample size for proportional data set. So for this one, there are 2 formulas. So I'll put right here 2 for topic 2. So you could either use this formula, or you could use this formula. And you do kind of want to just remember, like, when do you use, can you do an example of it? Yeah, we could do an example for E. Let me just finish with topic 2 right now. All right, so just remember for this one, there are 2 different formulas to determine how big of a sample size you should get. So in order to determine which of the 2 formula you want to use first, they have to tell you it's proportional, or essentially they have to give you the percent, but they also have to pretty much tell you in this one, p hat is not given. And this one, p hat is given. So if p hat is given to you, you want to use this formula over here. Because that way, if you look at your formula, that way it has p hat. But if p hat is not given, essentially on the front you put 0.25. So you do want to know when to use either one of those formulas. So you use the first formula when p hat is not given. You use the second formula when p hat is given. And just remember for n, it should always be a whole number. So if you find yourself giving me a decimal answer for n, you just kind of know that's already going to be wrong, because it should always be a whole number. And we're always rounding this up to the next whole number, because for this one, if you actually round it down, you're going to lose your margin of error. All right. Everybody good with topic number 2, or any follow-up question for topic number 2? Cool. All right, so what I'm going to go ahead and do, I'm going to go back to topic number 1 for chapter 9, and I'm going to go over how to find the margin of error. Since I already have this problem over here, I'm going to go ahead and use it. No need to make up 2 problems. Cool. All right, so that's the formula that is for margin of error. So the first thing what you want to go ahead and do is find what z alpha divided by 2 is. So to find what z alpha divided by 2 is, well, first you have to find what alpha is. So to find what alpha is, you do 1 minus your confidence level. In this case, confidence level is 92%, so you do 0.92, which is equal to 0.08. Any question on how to find alpha? All right, so then you get z of 0.08 divided by 2. So if you do 0.08 divided by 2, you get z of 0.04. So in order to find this, we're going to have to use our calculator. So in our calculator, what we're going to do inverse norm, and then you put this value in here. So let me go ahead and do inverse norm of 0.04. So turn on the computer, well, my calculator. So we go second, bars. You go all the way down here where it says inverse norm. And if you look right here, you put 0.04. Since we're trying to find the z value, you leave mu and sigma alone. So we go here down paste. You gotta enter. And if you look at it, it gave me negative 1.7506. So for this one, do be careful because on the test, I'm gonna put instruction on how many decimal places to get for the Z value. So if I tell you kind of going back to the quiz I gave you, this last quiz on Tuesday, like I told you like how many decimal places to give me for the Z value. So let's say if I tell you to do 4 decimal places, and this one you want to give me 1.750, and then if you look at 6.8, but the 8 is going to round up to 627. All right. So we get 1.7507. And just remember, since we're finding this for the margin of error, always put the Z value as a positive. Okay. So if you like, that's our answer. So we get Z is equal to 1.7505. Any question on how you get 1.7507 for the Z value? All right, I'll get that well, I'll do that answer once I'm done with this one. All right, so let's go ahead and do this the next part. So the next part will be, we get our margin of error. So for margin of error, we'll do 1.7507, and we'll multiply that by square root of 17 divided by 34, multiplied by 1 minus 17 divided by 34. And remember, you divide this by n. And n is 34. Right. So if you look at 17 divided by 34, 17 divided by 34, we actually already did this because when we found the confidence interval, if you remember, they gave me p hat. P hat is actually equal to 0.50. So you got 1.7507 multiplied by square root of 0.50 times 1 minus 0.50, all divided by n, which is 34. So this is what I'm going to enter into my calculator. So I'm going to transfer back to the TI-84. So we'll say 1.7507 multiply by radical 0.50 multiply by 1 minus 0.50, all divided by n. If you do that, you get 0.15, 0, 1. Yeah, so you find p hat by dividing x by n. So if you do 17 divided by 34, 17 divided by 34, that's the 0.50. Cool. All right. So that's our margin of error. So that's how you find margin of error by hand. All right. Everybody good for margin of error? Cool. All right. So there was one question on the chat where it said, "Hey, if we have a z value of 1.95996, how would I round that off?" So say if I tell you, oh, here, you can't see that. Let me switch back to my notes. Yeah, I figured that out. All right, so if we have z is equal to 1.95996, so today I tell you to round this up to 4 decimal places. So for 4 decimal places, that means you have to round this number up. So I had to use a 6 to round this up. So essentially, if you look at this one, we have to round it up. Because if you look at the 6 is greater than or equal to 5. So that means we have to round up to 9. So if you round up to 9, this actually become 10. But the thing is, we want it to be a single digit, so this will actually become 0. And now the 1 go over here. But now if I do 9 plus 1, that give me 10 also. So this become a 0. And now the 1 transfer over here. So now if you do 5 plus 1, you get 1.96. So technically that's the way you round it up. So essentially it's kind of like a domino effect. When you round up one number, it's essentially rounding up all the number all the way until you get to the 5. So you get 1.96. So if you do have like number like a 9, you kind of know like that gonna transfer over to the next number until you have a number lower than 9. But this one is usually for 95% confidence level. Like it will be kind of handy if you kind of memorize that, because we do use that a lot. So that way, instead of you having to find the z value for it, if you see 95% confidence level and you're finding the z value, you should already know it's 1.96. But that's how you round it up. Any question in regard to how to round up that number? So if you look at that number, if I do tell you round it up to 4 decimal places, well, you can only give me 2 decimal places, because when you round it up, it ends up as a 2 decimal place. So don't freak out. It does happen. All right, so let's do topic number 3. So if you look at topic number 3, it said confidence interval for the mean. So for this one is the formula where you use x bar plus or minus t alpha divided by 2. And this one you do s divided by square root of n. Also, if you're doing this in your calculator, this will be the t interval. So please don't confuse that with the z interval, because it will give you a slightly different answer and it will be wrong. So you have to just remember you want to use the t interval. And for this one, if I do ask you to do it by hand, in order to find this value, you're going to have to use the t table. And if you remember the t table is on Canvas. Cool. So let's do an example of that. Wait. All right, so let's do this. So we're gonna do a problem from National Geographic. Apparently it's Shark Week this week or last week, one of the week. So we're gonna do a confidence interval for the average amount of shark attack per the year. So let's say for 2019, we found that there was an average of 15.9 shark attack for 2019. And we took a sample of, I don't know, 30. And we get a sample standard deviation of, let's say 2.5. So we have the sample mean. So we took the sample mean and we found it to be 15.9 years. Well, it's 15.9 shark attack. And let's say n represent how many different years I collected the data set for. So I randomly selected 30 different years. And we got that the average shark attack is 15.9 with a sample standard deviation of 2.5. So let's say we wanted to do an 80% confidence level. So we're gonna do a 80% confidence. Look here, let me write it out like I'll do in the test. So we're gonna do an 80% confidence interval for the mean shark attack for the year. So we're gonna do an 80% confidence interval for the mean shark attack for the year. So if you look at this, we're doing a confidence interval, and we know we're doing it for the mean because they tell us it's for the mean. Because like in order for you to know if you're doing the confidence interval for the mean, proportion, or standard deviation, like I do kind of have to tell you that in the problem, so kind of rest assured. It should say confidence interval, and somewhere near confidence interval, it should say either mean, proportion, or standard deviation. But also remember for the mean, there are different words for the mean. It could be like life expectancy, or it could be average. So you kind of know all of those words just mean the mean. All right, so let's go ahead and do this problem. So the first thing what you want to go ahead and do is find T alpha divided by 2. So for T alpha divided by 2, the two thing that you're going to need is df, which is degree of freedom, and you're going to need confidence level. So if you look at this one, what's my degree of freedom? Cool, perfect, 29. And if you look at the confidence level is 80%. All right, everybody good? Degree of freedom 29, confidence level 80%. All right, so I'm gonna go to my T table. Let me erase all of this nonsense. All right, so for the T table, what you have to do, you have to look up degree of freedom of 29. So that's over here. Let me make this skinnier. And then what you have to do, you have to look for confidence level of 80%. So confidence level of 80% is over here. All right, so if you look at where do they intercept? So they intercept there at 1.311. Everybody get where the 1.311 come from, or how did I find it? All right. 1.311. All right, what's in there? Not here. So you get 1.311. So that's my T value. So if I want to go ahead and find margin of error is equal to T alpha divided by 2, multiplied by sample standard deviation, and we divide this by n, or square root of n. So T is 1.311. My sample standard deviation is 2.5. And lastly, my n value is 30. All right, so you get 1.311 times 2.5 divided by square root of 30. Any question in regard to that so far? All right, so let me go back to the TI. So on the TI, what you want to do, you want to go to 1.311. You multiply that by 2.5. And you divide that by square root of 30. So you go ahead and press enter. And you get 0.5. So I can't really get 2 decimal places. I'm going to get 1 decimal place. So if you look at this one, you can't really get 2 decimal places, because if you try getting 2 decimal places, the 8 is going to round up to 9, which is essentially going to round up to 5 to 6. So for this one, your margin of error is actually 0.6. So if you look right here, I put margin of error is equal to 0.6. So lastly, in order for me to get the confidence interval, we're going to get the mean and add it to the margin of error. So we get 15.9 plus or minus 0.6. So for this one, if you do 15.9 minus 0.6, you get 15.3. If you do 15.9 plus 0.6, you get 16.5. So for this one, I'm telling you that we're pretty much that the amount of shark attack for the year is somewhere between 15.3 all the way to 16.5. And that's it for how to find the confidence interval for a mean. If you want, you can also double check your answer by using the TI-84. So for this one, you go to stats, you go to tests, you go over here to number 8, which is T interval. We don't have a data, so we put the mean, which is 15.9. You put S, which is 2.5. You put N, where N is 30. You put confidence level, where we said it was 80%. You go ahead and calculate. And if you look at it, we pretty much get exactly the same answer. So you get 15.301, which is just 15.3. And then you get 16.499, which if you actually round it off, you get 16.5. So we get exactly the same answer. Like the only time you should worry if it's completely off. If it's completely off, either, well, most likely you did something wrong or you enter something wrong. But the calculator will not be wrong as long as the information you enter into the calculator is correct. But that's it for your example for the mean. Any question in regard to the confidence interval for the mean? Right. So that's topic number what, 3? And you just also remember for the confidence interval, the central limit theorem still apply from chapter 8. So the central limit theorem for P and the central limit theorem for mu is still applying for chapter 9. All right, so topic number 4 says determine the sample size for the mean. Let me see if I can jam this in. So for that one, the formula read as follows: Z multiply by S divided by margin of error squared. So for this one, if you kind of need an example for it, you might want to go to the example that I put about the cheetah, about me trying to estimate how fast a cheetah is, but I need to figure out how big of a sample size I need. So you might want to check that one out. But any question in regard to topic number 4? All right, so let's do topic number 5. Any question for topic number 5, confidence interval for standard deviation?
Good question. So since we're finding the sample size here, is there any way that we could apply central limit theorem if it's, do we have to apply it or not in this case?
For this one, no, we don't have to apply the central limit theorem, because for this one, they're just kind of assuming like these are the parameters that they want to put in their study.
Oh, okay.
So you're saying like at minimum, if you want a margin of error of like 5 or a margin of error of 5%, where you're telling us this is how much sample size you need. But like in order for us to tell them if it's gonna be approximately normal, you kind of have to go to the population, figure out if the population is already normally distributed. If it is, then it doesn't really matter if it's below 30 or something like that. But for this one, you never have to like kind of think about the central limit there if it's contradicting it. Pretty much for this one, you're going based off of the parameter, like what the minimum sample size they need. So don't influence it by doing the central limit there. Because if not, that will lead to a wrong answer.
Okay. Okay.
So you go strictly purely on the formula.
All right.
Okay. All right. So I guess no question for number 5. So remember, for question number 5, that one you cannot check your answer with the calculator. That one, the only problem that you essentially have to do by hand. So for that one, you do want to practice how to do it by hand. Like one of the things I will practice with the chi-square table, and just make sure you understand how do you get each individual value. So you should know how to get chi-square alpha divided by 2. And you should also be able to get chi-square 1 minus alpha divided by 2. So do spend some time with that chi-square table. Any other question or any questions? All right, sweet. So I guess that's it for the review. All right, so just quick little announcement. So just remember for the test correction, the last day to turn in is today. So do have them turn in by today, so before 12 p.m. or before 12 a.m., sorry. So you just have them turn in before 12 a.m. So you just have them before 12 a.m. so that way they could be on time. Also, just remember for tomorrow, we're going to go over chapter 10. So none of chapter 10 will be on the test. Is essentially a new chapter for a new test. Oh yeah. Here, let me do that now. So open up quiz 7. Where is quiz 7? All right, so quiz number 7 should be open up. So if you want to go back and double check your solution for that, or just kind of practice on that, just go back and just redo the problem. But quiz number 7 should be open. All right, but that's pretty much it for today's class. Because pretty much today was just essentially about review. So I'm not gonna go over anything new because essentially I just want you to have one relaxing day. So just remember, tomorrow we'll go over chapter 10. So you just have your chapter 10 notes. We won't get into like the math of chapter 10, where essentially you're gonna go over the terminology. But the terminology is very important for chapter 10 because it will help you. It will help you with the rest of chapter 10 because pretty much chapter 10, if you understand the terminology for chapter 10, essentially going to help you with the terminology for chapter 11, chapter 12, chapter 13, chapter 14, if we get that far. All right, cool. So let me end this meeting and then see Stephanie. Cool. All right, so that's it for today. I'll see everybody on Thursday.